Welcome to Calculus 1. Today we're going to review a little bit about what we so-called the inverse functions. What is so-called an inverse relation is the interchange between the x and the y coordinates or the x and the y variables. Okay, so when we see the word inverse, we want to interchange the x, y coordinates or the x and y variables. So let's say that, suppose here I got function f and g, such that the composite function of f and g will actually equal to x for every x in the domain of g, and if I do a vice versa, put the function f inside the function g, it will also equal to x as well for every x in the domain of f. Then we can say the function g is the inverse of function f. In other words, if we do the composite function of the two functions, if the answer come out to be x, then we can say that the function g is the inverse of function f. And for inverse function, we'll denote it as f inverse. Okay, so we talked about composition of two functions before. If I have two functions and plug into one to another, if they come out equal to x, that means the second function is the inverse function, okay, of the function f. Now, if the function is one-to-one, one-to-one is also referring to the horizontal line test. So if we say a function is one-to-one, then the following formula for its inverse can be found. So when we need to find the inverse function, we can replace the f of x with the variable y. Then we're going to interchange the x and y variable. Okay, the interchange of the x and y variable is the key component for inverse function. We will solve for y, then at the very end we will replace the y with f inverse. So let's try the example of using a linear function. Alright, we know this is a linear function, so a linear function give me a straight line. And the straight line is always one-to-one because it does pass the horizontal line test. It will only cross over the function at one point. So it is a one-to-one. Therefore, we can find its inverse. So the first thing I do is replace my f of x with the variable y. So we say y equals 2x plus 3. Second step, interchange between the x and y variable. Then my equation will look like x equal 2y plus 3. And now I will solve for y. To get my positive 2y by itself, we will need to move the positive 3 over. So I will end up with 2y equal to x minus 3. And to get y by itself, I will divide every term by the coefficient 2. So then my y is going to be half x minus 3 over 2. Alright, and at the very end, replace my y with f inverse. So my inverse function using the variable x will be half x minus 3 over 2. Okay, so let me kind of show you what's it look like in the calculator. So I'm gonna first type in my original function, f of x, 2x plus 3. Alright, so here is my linear function, and we just found the equation for its inverse. So I'm gonna go to y equal and type in parenthesis 1 over 2 close parenthesis times x minus parenthesis 3 over 2. And what I'm going to do is make my inverse function a little bit darker. I'm going to use a double line. So here, the second line here will be its inverse. Alright, remember now inverse is the interchange between the x and y variable or the coordinates. So here I can go to the table. Alright, and I'm going to show you real quick. For example, first function is 1 and 5, then I should have a 5 and a 1. Okay, interchange between all the x and y coordinates. All right, let's try another example with a rational function. And what I'm going to do is graph this rational function first. So let me come back here and clear it out, my two functions. Alright, two term up top, so parenthesis x plus 2, close it, divided by x. So here is my rational function. So imagine if I draw a horizontal line, it will actually pass the horizontal line test. So that means this function is 1 to 1. Then you probably notice that right here, this part of the graph look like a horizontal line, but it's actually not. As a matter of fact, the y value is actually decreasing a little bit at a time. That's why it appears to be a horizontal line, but it's not. Alright, so since it's 1 to 1, I can find its formula for the inverse. So I will replace the f of x with the variable y first. And then we'll interchange between all the x and y variable. So this y becomes x equal. The 2x variable will become y. So that will be y plus 2 over y. Alright. Now to get to solve for y, I need to bring this y from the denominator to the numerator. So I can, since I only got like two terms here, I can treat my x as x over 1 and use a cross product by saying x times y is xy, set it equal to y plus 2. Alright, now I got three terms. My variable y is trapped inside two terms. So what I'm going to do is have my variable y on the same side first before I can factor out the y. So I'm going to move this positive y over, and that will give me xy and then negative y equal to 2. Okay, so again, still my variable y is trapped into two terms. To make 2y into one of them, I can actually factor out the y, and that will leave me with x minus 1 equal to 2. So since I factor the y, this left side just become one term. So to get y by itself, we divide both sides by x minus 1. So my answer, y is going to equal to 2 over x minus 1. Or you can say my inverse function will be 2 over x minus 1. Alright. And that's how we find the equation for the inverse function. Alright, that will conclude this video. Thank you for watching.